crism is our newest X-ray telescope in space. It's a JAXA-NASA collaborative mission with ESA participation and will revolutionize X-ray observations of the universe. It does this with a one-of-a-kind sensor that captures data with 36 super-cooled pixels. Yes, you heard that right. This groundbreaking detector isn't measured in megapixels, it's a 6x6 grid of 36 pixels. But they're unlike any others. Although this detector, called Resolve, can create low-resolution X-ray images, that is not what makes it unique. Each pixel in Resolve is a microcalorimeter, so it can measure tiny amounts of heat. A 6-stage system cools it to 50 millikelvins, or a fraction of a degree above absolute zero. This extreme low temperature allows Resolve to measure how much a pixel warms when it absorbs a single X-ray, and therefore measure the energy of that one particle of light. It's basically a precise way of measuring the X-ray's color. As a result, crism can create the most detailed X-ray spectrum ever for distant objects. This spectrum can give a great deal of useful information, like temperature, what elements are present and in what quantities, and how fast an object is moving toward or away from us, even if we can only see it as a dot in the sky too distant to resolve details. This would be a revolutionary achievement for a detector with a single pixel, but Resolve has 36. This allows crism to observe extended objects that aren't point source dots and create spectrum maps of their different regions. That can reveal speed and temperature differences in extremely hot gases. Using that information, scientists can determine how nebulae and galaxy clusters have evolved and interacted over time. The Resolve detector was invented and built at NASA's Goddard Space Flight Center. The detector's success in crism will enable Goddard to further the design and follow up with X-ray microcalorimeters with hundreds or even thousands of pixels. So, while it may not sound as impressive as 4K or 50 megapixels, the Resolve detector on crism will be revolutionizing our understanding of the large-scale, high-energy universe. And that's pretty amazing for a mere 36 pixels.